Dylan Reese.
Carlos Castro.
Stephen DeBoy.
Empower people to travel by bicycle and to make bicycling conditions easier. So this is the USBRS. And you're going across the country, so you have been riding all day long, you're getting hungry, you're going to need to stop for food at some point, maybe you're getting a flat tire, or something's wrong with your bike, and you need to know where you should stop to sleep for the night. So you're trying to plan which town you're going to stop in. Now in the past you would have used a paper map to decide where you should stop, and you might have mapped out like some of the points that your friends told you should stop. We're trying to make an app for this so that you can access this information from your phone. So there's two really important features here. You need to be able to access this information offline, because when you're out in the middle of nowhere, most of the time you're not going to have Wi-Fi, and you probably will not have cell service either. So you need to be able to access this information from your phone without access to the internet. The other really important thing is you want to be able to crowdsource the information that you're getting from other cyclists, because the general population may not understand the way that cycling works. So, for example, there might be a campground up ahead, but if it's an RV-only campground, that's going to be really difficult for you if you're just on your bike. So having information from other cyclists will help to understand the specific accommodations that are best for cyclists. In order to do that, switching from rastered to vector-based mapping. So the first year of the Bicycle Touring Companion focused on getting a proof of concept out. The second year got it to an alpha beta prototype. Our goal for the third year was to get offline mode working and switch to vector-based mapping so that we would have a more robust implementation.
So, sometime during this semester where we had to switch from React to React Native. We're going to get into that a little more when we cover architecture later, but as a result of this, we had to rewrite a lot of our views. We had to recreate some of the functionality like creating accounts, logging in, changing your password, that type of stuff. We re-implemented like some of the vector map using a new library tailored to React Native. And we had to re-add in the point functionality, so creating the points, all that stuff, we had to recreate that. And there's also the offline mode, which was actually the reason why we did this technology switch. Again, we'll get more into the technology switch later in our architecture. But that's currently in progress, and we're working on getting that done. The nice thing was that we did not have to really recreate a lot of the database stuff. We were able to reuse the old database and just had to make a few new hooks into the new version of the application.
So with that being said, Performance testing, obviously loading all those points up in our map. We had to do a decent amount of work and kind of throw a lot of points at a small little mobile application. We got a lot of data out of that and are still working on getting it into a place where we can test the new implementation against those old performance vectors. We also updated a lot of packages. Obviously, whenever you switch from one implementation to another, it's a chance to bring everything up to date, make everything current and kind of the latest and greatest. With that environment set up, we did a lot of documentation and stuff to make sure that if there's going to be a next team that works on this, or say our sponsor John wants to go and take a look, install something, he can go ahead and do that, hopefully fairly painlessly, as we suffered through all of that setup and documented what our pain points were. And lastly, we did some user management, just basic register, login, working on changing password too. And that leads into React to React Native, but that was another big feature that John is going to miss with this, but it was a trade-off we had to take.
Our app server, which is where we hit all of our APIs and all of our functionality as far as logging in, saving sessions, and anything that deals with user validation or data validation. And that communicates with our database server, which is a CouchDB server. And the last component is our Mapbox API, which is actually how we load our map. We're using Mapbox as our technology. And we can pull that information down right from the API, so we can load our map and predefine it online on Mapbox's tool, and then load it right into our map. And that allows us all kinds of functionality, such as tracking user location, adding points to the map, adding components that are loaded when you click on those points on the map. And the last big thing with our architecture is this local PouchDB and the CouchDB. So Pouch is an adapter to communicate with Couch, and we'll get a little bit more into why this technology was chosen in just a minute. But the main functionality, the main reason to choose this database as our implementation is that it's designed for offline mode. It's designed to synchronize our data when we go offline and then come back online. Some of the new technologies we picked were React Native, and that was the main one that really drove a lot of our decisions as far as being able to use offline mode. And initially, when we first ported this app over, we attempted to take all of the old React components and just kind of shove them into React Native, and that doesn't work. So we had to basically rewrite our entire UI and a lot of the underlying functionality in order to do that. And as a result, we ended up losing Cordova as our way to build and our cross-platform, because React Native has a built-in cross-platform solution, and that's how we build our applications. And then Pouch and Couch, I've touched on a little bit, but the main reason we've selected this technology is the syncing. It's designed for an offline use case, so when someone's out on their bike and they add a new point to the map, it'll show up in their local database, and then when they come back online, they synchronize that information, and anything that's in their local database, as far as points is concerned, is also replicated to the live database, our production database, and anything that's in the production database is replicated to their local database.
That we had before, and which includes like location, centering on the user endpoints if you click on them, that kind of stuff. And it also allows like the points to interact with like our React Native components that we have. So the reason we went with Mapbox rather than Google Maps is the offline capabilities that Mapbox GL provides us with were a little more tailored to our needs. The Google Maps API kind of has some limitations on offline tile downloads, and it actually has usage limits, which would be a big like obstacle for us to really get around if we want to have a working implementation of this, because it would really limit what we can do with it.
The web application that we already had with the React.js implementation. So these were all discussions that we had as a team, had with our sponsor, and when it came down to it, he said, what is going to get me a delivered project that has what I need? And we came up with the decision that React Native is going to be the way that he can get the most out of this application. With that, we're going to go to a demo.
Certain point will provide. So again, if you're a cyclist out without internet connection, you might be able to check ahead, see points are there, and see what is available, and kind of planning your next stop. So in just a second, I'll finish up this and hit the add point. And then see we're back to the map, and now the cluster has 4 points because it was added in, as you'll see, Rochester, right there. All right, and that's adding a point on our app. Did you have questions? Right?
Yeah.
Any questions? Years back, React Native wasn't as developed as it is now, I guess, so it probably wasn't really a feasible option back then as well.
So the previous teams, when they chose React, were they not taking into account the offline functionality, or did they, do you think, was that just not something on the requirements back then? Or?
So offline was always a requirement. They did take that into account. They were using raster images, which I don't know exactly where they got those images. I think they were OpenStreetMap raster images, but they are very different than vector tile images, and retrieving those is much more of a
Vector tiles are
challenge.
more performant, and it was a major requirement to switch over to the vector map tiles so that we would have a better performing map and it would load quicker, especially when you're offline or don't have as good of a connection. So the previous functionality and implementation used those raster tiles, and that was the main reason why when we got this new requirement, we didn't continue with the old stuff.
Yeah. Another, to put it in perspective, the local area of just like Greater Rochester, you were to download vector tiles for that whole area, it would be upwards of like 600 to 700 megabytes, and that's not even like all the detail that you could go into. So we're talking, if you're downloading the entire United States of vector maps, that's a lot of data and not very feasible on a mobile application. So that's why it's kind of difficult.
Any other questions?
All right, it's time for food.
Now, before I go into our project a little bit, I want to first talk about the context of our sponsor as well as the inspiration that started this project up. So our sponsor was means that STARS is always looking for ways to update their resident software to be more efficient, friendly, and for more cutting-edge technology. So we were tasked with updating their booking platform, so that way instead of it being So from this, with just a quick glance, you're able to easily see what seats are available, what's not available, and where they are in relation to everything else. You're able to easily see if it's an aisle seat, middle seat, window seat, and if you're next to a bathroom. All of which, when you're traveling, everyone knows that the middle seat's probably not something you want, so you kind of need to know what's good and what's bad. And so we want to take this and kind of port it over with rooms and floor plans. So for what we got, with this information, we were able to get some administrative same building, even across multiple buildings. We want to make sure that they have the ability, that administrators have the ability to add this floor plan themselves and to designate these rooms themselves. Because if they didn't, they'd have to contact the representative, there'd be a lot of back and forth of trying to make a perfect template for them. And that's just a lot of wasted time when they could just do it all themselves. In addition with this, if you're adding your own floor plans, you need to be able to also update them in case a floor plan changes or if a room decides to get bigger or smaller based upon renovations. And you need to be able to have it so that whatever you designate shows up exactly the same way as it does to the students, because it'd be weird if that consistency wasn't there. And since administrators are a little bit on the older side, it's very important that there's a straightforward design to things so they don't get as confused. For the student part of requirements, it's something similar you'd see for an airline seat selection style. We have to make sure that they can view those rooms on top of a floor plan and that the view of those rooms change based upon the status of that room. So that way when you just glance over it, you're able to easily see where it is and if it's available or not. And of course, a student also needs to be able to view certain details about this room based upon, can I book here, where can I book here, and who's also living here, and also be able to create a booking through this interface to kind of cut off some additional steps. And of course, it needs to be easy to navigate and a pretty simple design. Test image right here, and we're going to add that in there. And then when they hit that Save and Continue button at the bottom, we throw this image into mGooCV, which is a corner detection software. Now, we use this corner detection software to give us a lot of points about this image. And of course, corner detection software is probably not perfect, so we need to allow the administrator additional functionality to deal with it. So they need to be able to select multiple points at a time, and then to remove these points if they happen to be not exactly what they need. And of course, also when they are in drawing mode, not in selection mode. See, selection mode, you cannot move points because we wanted to be able to mitigate as much error as possible. But when you're in drawing mode, you can move these points around to make sure that they are in the right position, or if the corner detection was just a little bit off. And of course, mistakes can happen, so undo and redo is a must. So what we need to do is now clean up the corner detection points a little bit and give the administrator some points that they can actually work with. Because what the administrator is going to be doing is going to be using these corner points to then designate where these rooms are, and these act as coordinates for us to draw. So we're going to get rid of the bottom ones, remove them, and now we have a nice cleaned up points for us to make use of. And we tried to make sure that this was easy to use, and we figured that corner detection would save users a lot of time, a little bit. Instead of trying to make sure they're perfectly on those exact intersections, we can do that. Now we're going to go ahead and skip ahead a little bit to when we're going to make the last floor room, because we don't really want to show that much there. So in addition to being able to remove them, we also have adding our own points themselves, in case there's a curve that you want to be able to try to emulate on a room, or if there's something that the corner detection missed. So once you add these points, you can then select them, and then when you are in selection mode, you're able to then create a polygon on the floor plan. Now this polygon then shows up exactly to the user in that same way. And then when you save it, we save those coordinates in our database for the display to the user later. Now we're going to go ahead and move over to a user, and it's a very similar UI as the admin, except there's some filtering out to the side. So we can remove any buildings that we don't want, which removes them completely from view, and they can be re-added if we need to. In addition to removing buildings, we can also filter out floors. Now notice as we remove those floors start to become grayed out. We wanted to make it very easy to see that what's available and what is not available to a user. So if it's grayed out, it cannot be clicked. If it's blue, it can be available and you can select it. Now when you select this floor, notice how those polygons show up pretty much exactly the same way as how the admin drew them. Now all the green means that it's available to this student, and we're going to go ahead and click on that, which gives us some additional information about who's booked there, currently nobody, and also where we can make our bookings. So we're going to go ahead and have Kimberly book an assignment in that room for that floor plan, for that room space. Now if we go ahead and sign in as a different user and go to that same exact floor, we should be able to see something very interesting as well. So if we go to that floor, again, you'll notice that all the polygons are very similar to how an admin drew them. Everything's green and still available. However, when we click on that, we notice that booking is still there. And we cannot edit that as some other user, which is very important. And again, notice how we are Jake Butler, and we cannot do that. So what we're going to do is we're going to have Jake then book in that available room space for us. And then what we do is we're going to add that room space, Jake Butler, confirm that assignment, and now Jake is also saved into our database into the booking that we can then edit or view later as admins. Now if we were to sign in as a different user to go to that same floor again, we're going to notice something a little bit different. Notice how the polygons that they both booked are now grayed out and unselectable. This makes us that way in that user is able to easily see what is and isn't available, and we gray it out. We also wanted to, this could be used for, currently it's just used if there's any room spaces available for like a booking. However, this could be easily expanded for additional information, such as if that room has a certain profile that fits to it and the user is not available, or the user doesn't fit that profile, that should also be grayed out. Or if there's any gender restrictions on that room, then that student can also show gray to them. However, currently it's just for if there's any booking spaces available.
because Angular just loads it just loads the required data in real time and updates the specific part of that page that needs changing. So for our project, Angular handles the interactions of an admin drawing on the floor plan and a user selecting a room. And on the backend, we're using Microsoft ASP.NET framework. We're using it as a web API, so it handles our interactions with the database and expose the API calls that a front end can use to grab information from our system. We're using the database that Stardust provided, but the data weren't built for our RESTful approach. So we make sure to perform some decomposition on the database models and turn them into view models, so it is easier to serialize. Module is the floor plans module. The left column inside that big box is are subpages that are accessible by users and also the admin. But on the right column, it requires admin access. At a certain point, like both columns leverage the Fabric.js library to draw and select polygons on inside an HTML canvas. And all the way to your right side, we are using services. And services apply the dependency injection pattern. We can inject the services into any module whenever we need to. And that's how we made our API service or services send web requests to the server. And our server-side architecture is basically from the left to right, mainly using the controllers and receiving API calls, and the models pulling data from the database with database access objects by, again, using dependency injections. And finally, constructing the view models. That will complete the data transferring cycle from front end to back end and then back end to the front end again. As mentioned before, we are using view models to serialize models into JSON form and pass it back as a web response payload to the Angular client. Along the way, we decided that we wanted to streamline drawing polygons for an enhanced user experience. So whenever our floor plan API controller intercepts an image of a floor plan, we use the mgu CV image processing library in the bottom left corner over there, and we pass it to the corner detection controller and to prepopulate the
sped up our front end work a lot. However, the rest of us didn't have any Angular experience, so we had to do a lot of catch up there. Fortunately, Dave did know a lot about it, and he could answer all of our questions, so we caught up pretty quick there. Another technology we had to learn was ASP.NET. Only 2 of us had used it before this project. So in order to get around this challenge, we assigned all the ASP.NET work to those 2 members. And as time went on, the other 2 caught up and learned off what we did. Using MUCV as our corner detection was very challenging, I'd say. Due to the lack of documentation for setting it up, it was hard just to even get a successful build. Once we did get a build though, there was more challenges. All the different floor plans that were available, it could detect corners accurately for some of them, but then for others it would either put points everywhere all over it or it just wouldn't find any corners at all. Another challenge was creating a positive experience, admin experience. In order to do this, we let them upload their own images as well as detect corners for them. When the corner detection worked successfully, it took out the frustration of them having to click each individual corner of rooms on floor plan. The last challenge for this project was merge conflicts. At some points in this project, we had people working on similar parts of the software. Because of this, merge conflicts happened, but we try to keep our communication up, and with high communication, we avoided a lot of merge conflicts. Given more time with this project, there are a few enhancements and new features we would like to add. The first one being user groups. User groups would allow students to invite their friends into a group, and the group leader would be able to assign everyone to a room. Having a feature like this would ensure that people are living with who they want to live with. Another new feature would be a final confirmation screen for bookings. So having this would just be a final check to make sure that the user knows exactly what room they booked. And by adding this, we believe there would be less users rebooking a room. There's also a few admin features we'd like to add. One would be zooming in and out on the canvas, and another would be auto alignment of the coordinates so that they're on the same X or Y. By doing this, the admin experience would be a lot better, and I think they'd really like it. For the student side, we would like to add tags onto the room. These tags would be right on the room and could show if the room is something like handicap accessible or the room capacity, things like that. There's also some general user interface and experience cleaning we'd like to do. One big thing here would be adding loading wheels where components take a while to load. Currently we have some spots where it's just white space and the user doesn't really know what's coming, if anything, so that would be very helpful. Another one here would be having our buttons disappear and reappear as needed. And the final step of this project would be integration into STAR as a system. We think we did a good job on the project, and it can be broken down and rebuilt right into their system. Thank you.
Okay, so the question was, do we have an ability, did we ever think ability of removing duplicate points or points that are too close to each other? Yes, and we tried that initially. It's just that you don't really know the dimensions of a room itself. So when we try to say, like, come up with some kind of algorithm of trying to figure out how close things are, you can't just, if you try to say, oh, just take the closest point, you're not sure if that point is here and then on the other side of a room, and then they combine together into an average. It's just a lot of messing around with it, and we figured it would probably just be easier to give them the raw, like not the raw points, but at least give them the points that are at least a little bit different, and they can be able to deal with that. Give them more information to remove than give them not enough and then be frustrated with it.
Mine was a similar question. Given how much work there is to remove all of the duplicate points in the demo, is it really saving the admin time over just drawing? I know you mentioned the being off a little bit.
Yeah.
On the dimensions of the room, but even in your demo, it looked like some of the points were creating lines that weren't quite lined up with the front end of the room facing the hallway, for example.
Right. So to answer that, when it works really well, when it works well, it works really well and saves a lot of time. It's just that there's like those certain cases where things are just a little bit off, like if it's like a certain different color, or if the line thicknesses are a little bit off, it does cause some problems, but we figured that it'd be better to be a little bit more accurate or to allow them that option as opposed to just forcing them to have to sit there and clicking for 15, 20 minutes trying to find each individual corner or trying to make sure you follow a curve correctly. And I figured it'd be easier to delete them than to try to literally draw them yourself like that.
I have one thing. Was there other like corner detection libraries that you looked at, or was this the kind of maybe the only option that fit your guys' needs? Like how did you guys land on that?
All right, so to answer so the question was, how did we land on MQCV? So we decided to land on MQCV because actually the go-to one is OpenCV, but that one's a different implementation and does not work nicely with C#. So that's not helpful. So there was a thought of like we could run a different like a Python instance and throw it in there, but we don't want to do that. However, MQCV has a very nice, it now has a very nice NuGet packaging that we can just get right into our project and be able to make a separate project for that, which made that really easy to set up for us. So it was more of like an easy setup for that one. Initially, when we did it, there wasn't a NuGet package, so we had to download these files, install these files, make sure you had certain DLLs, and doing all these things that are part of the project and inserting them in certain C. But eventually, as the project went on, there was a NuGet package that became available to us, so that made that significantly easier and more viable.
Did you use any CSS libraries?
Any CSS libraries? For the basic, just like navbar stuff, it was just Bootstrap, but most of the other, like most of the buttons was more of just like us making sure it was like sized correctly and making sure it's where we wanted them to be. Because although experience was something important to us, it's just that the styling itself wasn't the highest priority on it. Making sure they were in the right place and like the right size was fine. It's just coloring wasn't the top priority of this project. Mostly it was just getting points on a canvas and making sure they can save those points and making sure those are consistent across the different canvases.
All right, let's thank the team.
Thank you.
Josh, Ian, and Nate. We have been working by users' assets, related vulnerabilities through questions. And what we wanted to deliver Galarath was a framework so that they could fully build out the database, the assets, the vulnerabilities, in order to provide as much coverage as possible to a potential user. The four main components of our project are the UI, which you'll see as part of the demo, the C# backend, which is running the web application, the SQL database, which contains all of our assets, vulnerabilities, and how they relate, and then the algorithm, which takes in the survey data from the user and delivers relevant results. So we'll start into relate to whether they're secure or insecure by default. So if they skip questions on the survey, do we assume that they answered the most secure option or the least secure option? In the top right corner here, we also have our import and export feature. So if at any point during the survey they want to export their progress, maybe to revisit it later, or change answers, they can then re-import their progress at a later time. The reason we did this is we didn't want to save user data. It's highly critical to them. It would provide bad actors like a roadmap on how to attack them. So we leave that up to them. Moving into the survey here, the starting point is the tabs across the top, which contain assets that the user may want to protect. They can select any of these assets. There's also a tooltip if there needs to be more elaboration on or a description of the asset. When they select an asset, the sub-questions are spawned. They're queried from the database. And then sub-questions can also have sub-questions themselves, depending on the answers that are provided, which sort of builds a tree for the user to understand the user's attack surface. Questions also have tooltips if there needs to be more elaboration or description. So we'll answer some good questions to generate some results. Sorry. And then this is the setup of the results page. So results are delineated by category if a user wants to understand where they might be more or less vulnerable. There's also sorting by relevant criteria. And then if a result is not relevant to a user for whatever reason, they can bump it over into the hide tab via the hide button. For a result itself, we have the result title, a relative cost on an interval scale so a user could understand how much it may cost to implement, and then the main body of a result, which is the mitigation or how to solve the vulnerability. In order to provide some traceability back to the survey and the questions that they were filling out, there's also threats assessed at the bottom. Something that I forgot to note, the survey, you can fill it out to any amount that you would like, and then change between the survey and the results at any time to see new recommendations that are coming in based on your answers. Usability testing, we actually have a usability test plan, but in terms of time, we were not able to execute that.
Okay, so this is a high-level overview of our application. So as you saw in the demo, we have 3 different types of users: an enterprise, small business, and homeowner. Those users can then build their attack surface by answering questions about assets and vulnerabilities. And then the algorithm then takes all of that information and uses it to generate relevant recommendations, which are then returned back to the user. The way the data flows through the application starts with users' answers from the survey and also the recommendations which are stored in our database. The user's answers pass through combos, which combos are the different combinations of questions or different combinations of answers, which will spawn more sub-questions and also decide if the user is vulnerable to different vulnerabilities. All this information is then passed through our trimmer, which will filter out any kind of unsolvable vulnerabilities before being passed to the recommendation mapping algorithm, which does all the processing to return all the results. To do all this, technologies we use are Trello, Slack, and then for time tracking we use T-Metric, along with things like GitHub and other process tools.
All right. So when we were initially trying to create the data for the survey, we thought we'll just brainstorm some questions and throw them in there. But as it turned out, that led to very poor coverage of a user's attack surface. So we were thinking about it, and we thought back to SWN 440 with personas. And we thought, yeah, they're for UI, but maybe we can adapt them to work for our data creation process. So we created personas. For instance, you could have a persona for the owner of a small business, like a book bindery, or you could have a persona, the IT director at Strong Hospital. And they're going to have different assets. And so you can take these assets that the persona has and ask questions to figure out what we need to know about them to diagnose vulnerabilities and give recommendations. The database that we created at the end of last semester is very different from the database we have now. One of the biggest issues with it was the answers were directly mapped to sub-questions and vulnerabilities and other stuff. And this made it impossible for you to have multiple answers that would trigger a vulnerability or a sub-question, or have the lack of an answer trigger something. So to solve this, we created combos. And combos are something that can be triggered by combinations of answers. And once they're triggered, they can spawn sub-questions or activate vulnerabilities or whatever you want. The way the combos are triggered, we borrowed a concept from computer engineering and electrical engineering called minterms, which is a way to represent the Boolean logic equation, the Boolean logic equation for a circuit, a logic circuit, except instead of using wires, we're using answers, and the answers can either be activated, or they can be selected or not selected to activate the combo, and you can have different groups of answers activate the same combo. One of the other issues that we found with the database that we didn't foresee, we figured we're fairly technical people, our sponsors fairly technical, so we could just enter all the data through SQL Server Management Studio. But as it turns out, entering hundreds of lines of SQL insert statements is quite tedious. So we figured it would be more efficient to write thousands of lines of C# and JavaScript to create the database user interface. And this allows for the creation, reading, updates, and destruction of all the data within the database. It allows us to visualize the data much better, modify it more easily, and it also gives spell check because it's running in a browser.
So next on to the actual algorithm that ties the user's vulnerabilities to the results we want to give them. The basic idea is that the algorithm itself takes in the user's vulnerabilities and all of the recommendations that we want to look at and figures out which collection of recommendations solves all of their problems for the lowest total cost. And on the image shown on screen, we see that it gets this information from the trimmer, which kind of sits in between the algorithm and all of the information that the user actually gives. And the idea of the trimmer is to just simplify the problem and to remove vulnerabilities that the algorithm wouldn't be able to solve given the recommendations. And one thing we wanted to do was to have it filter out recommendations that the algorithm would have no reason to pick, but after some performance testing, it actually turns out that it's faster just to let the algorithm deal with them than to cut them out ahead of time. Now, as you can also see on screen, the requirements for the algorithm were for it to run within 5 to 10 seconds with 100 recommendations and vulnerabilities. We wanted it to be deterministic so that it would be easy for us to test. And a big part about the idea we adapted of building a framework was that we wanted things to be easy to build on top of. So all throughout the project, we're thinking of having a very low cost of maintenance, and that extends to the algorithm as well. So the algorithm that we're basing the recommendation algorithm off of is based on a solution to the set cover problem. And that's because when we look at the problems side by side, they actually have a lot in common. So with the set cover problem, you have a set of elements, just like with our recommendation mapping problem, except the elements are representative of the user's vulnerabilities. We have subsets of this set, and in our problem, those are represented by the recommendations, which each solve subsets of vulnerabilities. And each of these sets has an associated cost to them. The real difference is that within our problem, the recommendations may solve vulnerabilities that lie outside of the global set of vulnerabilities we're trying to solve. So that's part of what the trimmer was for, and for performance engineering that had to go on. So while this set cover problem does have a lot in common with our problem, there are cases where it is slightly inaccurate. And the short version of what the set cover algorithm does is it looks at all of the elements represented and all of the sets represented, and it finds the highest cost effectiveness, where a set solves the most elements for the lowest cost ratio. And the set that does that most efficiently gets picked. All of its elements are removed from the global set, and then we rinse and repeat until all of the elements are removed, and that's how it works. Now, when it comes to cases like this, where we have pretty large sets with similar costs and a lot of overlap, sometimes it may pick a set that is most cost effective in the moment, but will lead to a less cost effective combination of sets in the end. So if you pick the most cost effective set on each round of the situation described here, it will pick set 3 and then 2 and then 1, but then it's picking 3 sets to solve one problem. And in this situation, we're just setting all of the costs equal to each other. And then, but the thing is, we know that sets 4 and 5 could solve the problem together for a lower cost than the other 3 together. And this solution that's given isn't, well, it is inaccurate, it's inefficient. And that's part of why, next slide. That's part of why we considered numerous other approaches and different ways to solve the problem. However, within the constraints of our requirements, we still deemed the set cover solution to be the most appropriate with some minor changes. Now, some solutions we've tried, as you can see, were genetic algorithms, and the problems there were they lack determinism, so without proper seeding, they could be difficult to test. They were often slow, and given that the algorithm has to run pretty often, we can't afford for it to be slow, not to mention it conflicts with our timing requirements. We also tried a slight modification on the set cover algorithm called the repeated set cover, where it would cut out that problem set that it gets in the beginning and then try it again. But it is guaranteed to be more accurate than the set cover algorithm. However, it's significantly slower, and the it still doesn't solve the overall problem that leads to an inaccurate case. And the final solution we thought of was creating a lookup table, which would be perfectly accurate. It would be fast at runtime, and of course it would be deterministic. But the problem is having to recompute it through maintenance. It drastically increases the cost of maintenance of the overall project, which isn't good considering we're trying to build something that people can build on easily.
All right, so for documentation, our goal was that the next team that works on it, be it here at RIT or at Galrath, they can pick up right where we left off. And so to accomplish that, the database UI has an entire page devoted to documenting all the tables in the database, what data is in there, and how it's used in the Cyber Advisor. The information there is also exported as a PDF so that the next team doesn't have to build the database UI to get that information. We're also going to be doing a refactor, going over and making sure that our code quality is up to par and the readability is there, as well as adding comments. The data creation process that I went over with personas, assets, and questions, each step of that is detailed in a document along with the reasons why we think each step is necessary and how it contributes to better data coverage overall. Finally, Nathan worked on a white paper detailing the algorithm, how it works, what its advantages are, what its disadvantages are, as well as all the other approaches that we've tried that haven't worked and why they're less optimal. With that, we'll hand it over to you guys. Any questions?
So when you're using combos, does that mean that, how does that handle questions that have like multiple answers besides just a yes or no? Can you not handle that? You have to break that down into multiple questions, or?
So when we're handling questions that have that's more than just a binary yes or no, each one of those answers is an object in the database, and each one of those is looked at by combos that they're mapped to determine whether they've been selected or whether they aren't selected. Because some combos might be triggered when some of those questions aren't selected. Anything else?
Do you have a feel for how well the application is working? I mean, does it actually offer reasonable suggestions?
So far as our testing with our test data, the recommendations are accurate, but it would require the database to be built out with all of the assets in order to provide full coverage to a user.
Yeah.
We believe our proof of concept does show that that's possible.
Yeah, for the limited data we have, it seems to work pretty well, but our focus was on the framework, not necessarily the data, so the data definitely needs to be expanded to be applicable to a wide variety of people.
All right, let's thank the team.
All right, we are the smoking cessation team, kicking butts. I'm Justin Haddock.
I'm Austin Cowan. I'm Graham Holm.
I'm Holly Hastings.
All right, so 17% of the U.S. population still smokes cigarettes, and despite all the propaganda and all the knowledge that we know about it, although of these 17%, 68 of these do want to quit when you survey them, so the drive is out there. 90% of people who try to quit smoking relapse mostly within the first month, so it shows that the current methods out there aren't super great. And current smoking cessation apps, if you go on the App Store and try to find something to help you quit, they're going to find basically just journaling tools. You may find some things that show you how much money you're going to save or give you like inspirational quotes every couple days, but nothing really sticks with you and shows you holds your hand with the quitting process. So why we're going to be better here is we're going to use you have the use of cognitive behavioral therapy techniques within our application. And these are really trying to rewire your brain and understand where your triggers are and what your motivations are for quitting, and adapt these into a treatment plan that will provide better results for people who really are serious about quitting smoking. And with this, we're going to use timely interventions targeting individuals' triggers. So, for example, if someone goes out on their balcony at 5, or they always go on their balcony to smoke at 5, the application made to be able to detect this and provide an intervention, maybe a memory game or something to take their mind off of it. And it'll understand their motivations. So if someone at the beginning said they're doing this for their health, you could say, think about being able to run a 5K eventually or something like that. And we'll support custom treatment plans for at the beginning of the application. The people on the admin side, which would be a researcher, clinician, or a therapist, will create a pre-quit survey and custom interventions for the individuals on the other side, the smokers. And this will enable data collection of smokers for research. We are complying with HIPAA guidelines, which is basically the guidelines for medical information. You can't have any information that might be able to identify an individual. And with this, we'll be able to further our understandings of how people smoke and their habits of when they quit by gathering data on actual smoking events. And we have a demo here of what we have so far. Okay.
All right.
Do you want to go through it?
You go first.
So we see that we first can enter a custom terms and conditions that all users will have to see. We had one on our bar here, and it has these B tags. You notice they're HTML markup. When these go through, these will be implemented on the app screen, which is on the right there. We're going to push that.
All right, so now I am, let's say, someone who smokes, and I'm using this app. So I'm going to view the terms and conditions, and as you can see, I get the same terms that the researcher put in on the web app side. So I tried to continue, but I didn't check a checkbox at the end of the terms and conditions that shows that I actually read it. So, but now I don't want to accept it, and the application tells me that I can't continue unless I do accept the terms and conditions, because you need to be able to agree to what the app is, what the researcher who is using your data wants you to agree to. So now I click accept, and I'll back over on the web app side.
So now that our user has accepted that, we can go in and make a survey for them to answer pre-quit. So we're going to have a couple of questions here. A question that elicits a text response. We're going to say, how long have you smoked? We're going to enter that there and submit the question and make another question. And this one is going to be, why do you smoke? But I want to know this first. I want to know this before we know that. So we're going to index this as the first question. And that will push the other question back so you can customize where questions appear as you create the survey. We're going to submit that, and we get the survey ID, and then back on the smoker side.
Yep, so I'm going to take the survey. This is why did you start, and of course I know this means why did you start smoking. So I'm going to say, because, oh man, I didn't realize how slow the typing was when I was doing this, but you get the idea, because everyone else was doing it. All right, and I'm going to proceed to the next question. It says, how long have you smoked? I'm just going to fill that in. And hit next. And the application tells me that my data was saved. So now on the web app side.
All right, so as a researcher, I want to be able to see this data. So we can go back here and get some survey responses, input the user ID and the survey ID. We know that this individual is 0 in the survey ID we just got. And here are our survey responses. So why do you start? Because everyone else is doing it. And how long you smoked? For far too long. One of the key points functionality here is exporting it in the CSV file, because this is actually manipulatable data. So we're going to bring that into Google Drive and upload it. and it doesn't take too long. Open up here, and you can see that we do have a question ID, index, question answers, all the data you would need to run whatever kind of manipulation you're going to off of there.
All right, so that's our demo. Back to the presentation. All right, so we're going to go over our system architecture. Down here, where the Android guy is our web app, our mobile app. That was built using Android Studio, and its job is to, as you saw, have the user agree to terms and conditions, have them answer a survey prior to starting to quit, and then to allow them to track their smoking events. So whenever they smoke a cigarette, they can enter it in the app. Now, of course, if they forget, they can go in and do it retroactively. But when they do it at the time of the event, the app collects their geolocation data as well as the current time and stores those, along with a short series of questions that ask the user about how they're feeling at the time that they smoked. That data is then uploaded to our backend server, which was written in PHP and uses a MySQL database. And then it can be viewed on the web application by the researcher who's looking at this data, or the therapist for the person who's trying to quit, or whoever it may be. Basically one of those two. And the web app was written in Angular and Node.js. Now, of course, data can go the other way too. As you saw, the researcher or the person's therapist can create a custom set of pre-quit survey questions so they can get the specific data they want from their patients, send that to the web app, and then the Android app, or you can send that to the backend server, and then the Android app will download it when the user opens it up and enters their therapist or their researcher's access code.
So for our technical challenges, one of the big problems we had was implementing HIPAA compliant software, because we found that we didn't really have the money to have other people do things like create a HIPAA compliant database for us. So we had to work on creating that ourselves. That really affected our database design and also kind of pushed back development sometimes. We needed a highly normalized database because data integrity is really important in HIPAA. And
all right, and another technical challenge we stumbled across was the problem of integration, because we were developing 3 separate systems. We were developing an Android app, a web app, and a backend server, all concurrently. So one thing that we found really challenging was getting a feature complete end-to-end across the system. So it might be okay on the Android app side, or maybe okay on the web app side, but maybe not on the backend server, or some combination of the 3 would be complete, but not all of them. And so we learned to have regular integration checkpoints before the end of our sprints, when we were supposed to deliver the feature, about halfway through the sprint. So we could bring to the table what we each had so far and work together to integrate it and finish feature completion across all 3 parts of the platform. Getting HTTP requests to work and establishing an API and adhering to it across the Android app, the web app, and the backend server was part of that integration challenge.
Yeah, one of the things that had to do with the HTTP request was a CORS issue, which is cross-origin resource sharing. Having Angular speak with our backend, we weren't able to get that figured out until after the first semester, pretty much. So we didn't have anything integrated until the second semester with the web app talking to the database, but we were finally able to get past it.
All right, on the Android app side of things, one particular challenge was creating a dynamic UI for things like survey questions and terms and conditions. When the user goes to use the app, there could be multiple sets of terms and conditions they could have to agree to. And as you saw in the demo, there can be any number of survey questions. So the Android app has to be able to, on the fly, create inputs and views for all these survey questions or terms and conditions or what have you. So that was sort of challenging to figure out. In the end, what we did was we reused the same activity, and it would sort of call itself recursively to display however many questions or terms and conditions there may be. We also simplified the survey down to just support text questions for this release, so we wouldn't have to build views for all the different types of questions we want to implement eventually, such as sliders and multiple choice and so on.
On the web app, a lot of the focus was on the survey creation. You can generate a UI and create a survey for many different types of questions. We had drop-downs, checkboxes, all the typical standard things you think of, and sliders, responses. And I tried to use a library for this, and many do exist, but implementing those into their application would have required a lot of refactoring the whole architecture of it, and didn't want to do that. So we just kind of made it from scratch, and it works pretty well. And the data comes out of it is in JSON. It's pretty works pretty well back and forth for the database, and we're pretty proud of it.
So when we first started the project, we just kind of tried to throw some tables in there that weren't very thought out that well. Just massive amounts of columns in singular tables, and we eventually down the line we had to break that up for HIPAA guidelines to normalize it, and that pretty much destroyed all the functionality I had on the back-end API routes that I wrote. So that was a big hurdle we had to get over, was reformatting all the API routes to account for the new database tables that we had to create. Another problem we had was just our VM got shut off several times because there was just back-end processes that Kurt got really angry about, and he just kind of shut it off and didn't tell us, and we couldn't really figure out why nothing was working anymore until, I don't know, he finally explained why he was shutting it off to me, and we got it figured out, but yeah, that happened.
Okay, so for our documentation, we kept most of our requirements as user stories in Trello, and also we would keep burn down charts and spreadsheets to track and show to our sponsor that we had completed the stories.
All right. We also, of course, have a robust project plan. We just show like one small page of it here with risk management. We track those throughout the project and, of course, documented them in our 4-ups. And we also, at the end, wrote a final set of documentation so that this project can be handed off to another team who will be able to learn what we've done so far, why we made the design choices we did, and continue along the development path that we've started. So that's what you can see over here with the, here's the Android app final documentation, just a page of that.
All right. Yeah, so for future features, one of the main things that we want to do is be able to help people quit smoking. We haven't really gotten to that part of the application yet. The first part of this is being able to track whenever you have a cigarette. So you track the location, time, the mood that you were feeling, and whatever triggered the specific situation. So you're supposed to, the user of the Android app is supposed to just log every instance they have. The second point we have on this is being able to learn from those logs that they've created, which is kind of more complex, but that's something that has to be done in the future. So you can get those just-in-time notifications. So if you have several logs that you just have, like Graham said, you go out on your deck at 5 o'clock every single day. The app should be able to learn from that in the future, and before you get there, if it realizes you're standing in that spot or it's that time, you get a notification that says, hey, are you about to smoke? And it will be able to provide whatever specific motivator that you have. For example, you get a notification that has like a picture of your family or something on it that you can set yourself. Another feature we wanted to implement was just having more information about how CBT, cognitive behavioral therapy, works, and different techniques, so the user can kind of understand why this app is doing what it's doing and how it does it. That's it for that.
All right, open it up for questions. All right.
All right. Oh, okay.
Yeah.
So, you mentioned that the activity in your Android app just calls itself recursively.
Mhm.
Did you consider using fragments at all?
We did look into that, yes. In the end, it was a question of like how much time we had, and so yeah, it kind of came down to that. But fragments would definitely be the way to go for future development, and that's going to be specified in the documentation as well.
Did someone over here have a question?
I was just wondering, do you guys consider bringing this app to anything besides smoking, like drugs or alcohol?
That is a very good question. That is actually, that was actually one of the requirements, that this app be able to be customized for other applications to help people quit other habits and not just smoking. So for that reason, we designed it, the Android app, for example, with strings that can be swapped out so that, you know, it doesn't have to refer to smoking, it can refer to something else. And of course, that was also the rationale behind, or one of the rationales behind allowing the researcher or clinician who's setting up the app to customize the survey and customize the terms and conditions and what have you, so that they can customize this app and how the user sees it to be for any sort of therapeutic application you can think of.
Yeah, and the web app site actually has no references to smoking in it, so it is just a general use platform. Over here?
Yeah.
You guys consider for the mobile app using some sort of web technology instead of a native app so that you could more easily transfer the survey from the back and the front, and that might be easier to display.
Right. Yeah, no, it was actually a request of our sponsor that we implement the app in Android. By the way, our sponsor is Dr. Joseph Bashnagle. He's in the back there. I just want to give him a shout out. And our coach was Cal Raub. And actually, yes, so that was a request of Dr. B that we implemented in Android. He has an Android phone, so it allowed him to try it out pretty quickly. I wrote the Android app, and I had a lot of experience with Java, so I figured, going native was the way to go. And so yeah, and cross-platform compatibility wasn't a requirement, so it wasn't really something we took into consideration or decided to go down that route for this project. Any other questions? Well, thank you very much.
Good afternoon, everybody. Before we introduce ourselves, I'd like to also introduce two other people that were on our team. That was our coach, Yasmin Helgely, and also our sponsor, Jim Bondi. They've been great assets to our team as well. My name is Arshdeep Khalsa.
I'm Dominic Cecilia. I'm Daniel Roach.
And I'm Alan Liu.
So to start us off, we have a quote from our sponsor, Jim.
We are interested in companies that will recruit RIT majors but don't come to campus. So as we talked to Jim, we discovered that companies have issues reaching out to RIT students. Companies in various geographical locations want to connect to students, but they don't always have the funding to fly us out for on-site interviews. If we don't conduct the interview in person, some students might have trouble easily sharing their work with the interviewer. For example, a designer with their handbag or an interior room designer, those products can't be fully showed off just with images. And lastly, we have problems related to interpersonal communications in regards to the environment. And what that really just means is it feels a lot worse to talk to someone in Skype rather than in person.
Awesome. So that was 3 of the major problems that we identified. Now we had 3 solutions to this. So because people are in different geographic locations, we provided video streaming within our application. Alan mentioned a little bit about Skype, but we'll show you how we had our own little twist on video streaming a little bit later in the presentation. We also mentioned a little bit about the live feedback from interviewers. So we wanted to make sure that interviewers could exhibit their work within the VR environment, and we'll also demo that a little bit. One of the other things we really wanted to focus on was this environment aspect, and this was something that Jim really harped on. So within the VR environment, we can really control where the interviewer and the interviewee is. When you're in a busy office setting, or if you're even in a team room, it feels very different than feeling like you're in a one-on-one interview with another person.
So our overall architecture involves about 3 submodules that we went over. So we have the web application, which encompasses our database and our API that we use, but we also have a VR application and web real-time communications that includes video and audio streaming. And all of these subcomponents are wrapped into our one application, and we're going to touch on all of those. Also, design trade-offs that we had to make. We went into looking into Unreal Engine, Unity Engine for and standalone applications to see what would work best for our solution. What we went with was a mobile solution or a web solution that allows us to extend to a whole bunch of different devices, and it's highly accessible.
Awesome. So as Dom touched on, our application essentially was made out of 3 sub-projects. One of the larger parts of the project also was having a web application. So in this diagram, or in this slide, you'll see some of the things our API was used for. Room data management. Now, room data management consisted of different backgrounds for our VR environment, the actual assets that an interviewee wants to show the interviewer, and we also supported single file uploads as well as multi-file uploads. And we'll show a little bit about how we did that. Some of the technologies that supported our API was Node.js with the Express framework. We used Mongoose, which was a mapping tool to our MongoDB database. So a very high-level overview of our architecture when it came to the web application was we used React on the front end and encompassed A-Frame, and Dom will touch on that a little bit in terms of how we used it in VR. And we also used Express.js with Mongoose to interface with our MongoDB. So essentially, we provided a REST API for our React components. They were able to utilize that to manipulate data. At the bottom, I added a little bit of a visual because I feel like sometimes with an architecture diagram, you might not be able to realize how an application uses it. So at the bottom, correspondingly, you'll see with the React component, you have settings and a picture. The settings in the picture is actually retrieved from our API, which you'll see in that sample response there. And in the backend, we also, or in the database, we also have separate documents. Each document consists of separate rooms, which we'll show a little bit later as well.
So the second component of our project is interview rooms. So interview rooms consist of creating rooms, joining rooms, and performing calls. So this functionality was largely provided by EasyRTC. So EasyRTC is a real-time communication framework that we used here. So for our idea of interview rooms, we use EasyRTC in conjunction with our API to sync the idea of rooms existing on our server with our API. So with that, you are able to create rooms, join rooms as needed. And then for calling, we just use a signaling server to get calls out between our clients, which will be our interviewee and interviewer.
Okay, for the VR side, we needed the ability to show the interviewee and the interviewer like all these assets. So we needed transitioning in 3D, we needed rotation, we needed to create the object, we needed removal of the object, we wanted to be able to dynamically upload these images in VR so someone in VR can select these objects and bring them out. So you don't have to do it on your desktop, then you put it on the headset, you can just do it seamlessly through the whole thing. So on the left over here you see
just a development example. So this was in development, like a month or two ago, and we're just like moving around some assets, showing this is going to be more in depth in the demo that we do. So for the component overview, A-Frame is built on entity state architecture, which is a very game-heavy architecture that focuses on like really working with, you have an entity and then you have components, and the components can manipulate the entities. We created our own components for VR because we needed to be able to manipulate, rotate, and do all these things that third-party applications didn't offer us right away. So we had wrapped all this into our own React component, and we just put that in the VR scene. So here's our demo.
So to start, we'll talk about room creation. So in this scenario, we have an interviewer who is going to reach out to a potential new software engineer for their new program. So to start out here, we will have the interviewer enter GRR. So here they're able to see all the existing rooms we have so far, and they're going to create a new interview room for their new potential employee. So here they're able to see who's in the room and join it as needed. So on the interviewee side now, this person sees a potential new job in the next great company, Microgluzon. So here in his email, he has a link to the interview room which he'll go into to start his interview.
Awesome. So here you'll see that the interviewee has joined the room. So now to show you a little bit about the VR environment, we're going to switch back into the interviewer's view. Within the interviewer's view, we have a settings menu. We touched on this a little bit. So this is some of the data that we allow our interviewers to handle. So you actually have a VR mode toggle. Now with the VR mode toggle, you can actually conduct the interview in VR mode, or you can just do a regular video-to-video stream without any of the VR capabilities. You also can choose a background image. We'll see here we have Venice, and then you also have assets that you can choose. So the interviewer is prompted that the interviewee has joined the room, and do I want to accept the call? Sure, I'll let Dan into my room. And then we'll see here, Dan has actually entered our room. He's floating on the ocean. So from here, we can actually pick which environments we want to put our interviewee in, or where we feel comfortable. So this is just a list that we actually queried from our backend. We can put Dan in the jungle if we'd like. Let's see, that room didn't work out, right? Let's go somewhere else. The safari. I don't think Dan's ever been to the safari, so we take him there. We have some friendly lions, a lot of friendly animals out there. And as we continue on, you'll be able to see that as an interviewer, you have a lot of power over your environment in terms of where you can put it. So some of these are funny, but there might be some work that you want to show in different environments. So if you're a medical illustration major, you might want to show your work in a doctor's office rather than a one-on-one interview room. So now we decide that none of these are cutting it for us. We try to utilize our handy upload form, and we utilize a form to upload our 360 image. I think Dan is tired from his travels here, so he might end up taking a nap on that table, I believe, in just a couple seconds. So.
So now looking at asset manipulation. So if we pause here, you can see that on the left hand you have your asset selector, and you also have a tools menu bar. So as assets get populated, which we'll see later, there'll be the icons there that you have the option to add a picture there if you want to know which icon or which asset you're uploading. So as he goes, he selects the asset, and he's able to put it in the environment, and he's going to select another and then put it in the environment as well. And this is from the interviewer's perspective that we're demoing right now. So he can manipulate it, rotate it, and then he's going to grab the eraser. So if you see, he has the eraser in his hand. He goes up, and if he hovers over, there's a red box that appears around the object, and then you can click it, and it removes it from the scene.
Awesome. So one of the other features that we wanted to allow as we talked to our sponsor was he really wanted to highlight the fact that interviewees should be able to upload their work so they can show it to interviewers. So we allowed interviewees to be able to do it through an upload form. Currently we support .obj extensions, which is something we did research on. We saw software like Autodesk allows for it. So here you'll see that the interviewee will choose multiple files, and this is where we do our multi-file upload. So they're restricted to an MTL file there, they're restricted to an OBJ file, and then they choose texture fields for their 3D object. So this is again from the interviewee's perspective. They upload that file.
And then we go back to the interviewer's perspective. They look at their bar, and the interviewer's like, we just uploaded something, and there it is. So the person goes to it, grabs it, and it's like, okay, what's this? You wait for the textures to render, and then boom, you have your object in VR, and the other person has uploaded this and are able to manipulate it. And as you see in this environment, you see Dan in the interview. He's there. You can talk to him in the same view, and you can point out just things on your asset that you have. So this allows you to manipulate 3D asset and talk to the person in the same environment within this an environment that is comfortable for you. So he's just moving it around. You want to use Cessation? Okay.
So these are just some ways we could potentially extend our project in the future. So we could increase room capacity beyond 2 people. Right now our video call system is only peer-to-peer, but we could look to add more people through a centralized server. We could also look to add real-time text chat. So for example, we could share links, or let's say a student in RIT is hard of hearing, he could just type to the interviewer and he could type back. And then as previously mentioned, right now we only support very specific 3D asset files, so we could support other extensions, and then potentially be able to share videos as well for game clips and animations. And then obviously we'd like to update our project as VR technology gets better in the future.
So we are going to all go through and just talk about some reflections and lessons that we learned throughout this project. So you want to start, Dan?
Okay, so for me personally, going through EasyRTC, this is one of those frameworks where normally you can just kind of skim through it, then start and figure the rest out later. However, with this, what kind of happened was that a lot of the functionality is kind of hidden. So it's very powerful, but very hard to understand for when we needed to manipulate it for our use. So I had to spend a lot more time out of reading through documentation and figuring out what actually is happening in EasyRTC.
In terms of the VR side, I did a lot of the VR work on the project, and I found that even with my background that I've done a lot of this VR work before, it still took me at least 4 times as long to complete something that I wanted to do in VR than in a regular web application. Also, our limitations on the VR state right now, we had to choose between different types of applications that are limited, required high performance computers, and see what is capable today, and that was a huge limitation that we had to choose to overcome.
We had some trouble deciding how we wanted to go about this. So originally we actually looked into setting up a multicam setup for creating a 3D model of the person to put in the VR environment, but there were so many problems and constraints that in the end we decided to just go with the green screen.
And one of the things that we identified, so the scope of this project was quite large. We did consult some other professors and all that type of stuff, and found the best way to really go about it was each individual team member owning a part of basically a piece of the puzzle. So like I said, someone was handling a lot of the video streaming, someone actually ended up handling the web application, so that meant the front end, the back end, our database, and then also, like Dom said, handling the VR stuff. So it ended up being 3 sub-projects, but we found if we could have each individual team member kind of lead those endeavors, we would be in a better place and be able to integrate as we go. So, any questions?
What are you guys mentioned that what are trade-offs with making sure that you didn't need a super powerful PC to run this? What kind of performance requirements are needed to run it as the person in VR? Is it the same as Steam or Oculus requirements?
Yeah, so this actually goes into what our application is capable of. So we can actually, the interviewer or the interviewee can be in VR or they cannot be in VR. They don't have to be in VR. So if they don't have a VR headset or they don't have a capability of going in, that's fine, and they can just use a regular computer and it doesn't require anything. We are specifically targeting the Vive headset for this deployment. And in future iterations, they are capable of extending it to other VR headsets, as A-Frame is extendable and it can access any VR or AR headset out there on the market today.
And also to add on to that, one of the benefits of making this a web application over a desktop application was the fact that you're limited to your browser's capabilities rather than what you might be limited to in terms of your desktop. So like anything your browser can do, usually on the computer, you should be able to handle it.
Okay.
Awesome.
All right.